So hello guys, my name is Ritik and in this video we are going to learn about line plot, what is a scatter plot, how, why we use plotting a line plot, and also we are going to discuss histogram, what is the univariate analysis, what is a bivariate analysis, and what is a multivariate analysis, and what is the need of using a histogram, right? So before we go into deep dive, we are going to discuss how to plot a 3D scatter plot and what is the need to plot 3D. So here is the code. So if you want to plot a 3D plot, we have to create a CMap. To create a CMap, we have a function called blt.get underscore CMap. With the help of this function, we are creating a CMap. After creating the CMap, we are going to create a projection or axis for 3 dimensions. So for that we have a code called plt.axis. The parentheses we need to pass projection is equal to 3D, and whatever value it return, I will store that into axis. And after that I need to write, if you don't want to write this code, then it doesn't affect much. And after that I'm going to write axis.scatter 3D. It basically plot all the data points into 3 dimensions. So here we have axis. First axis is equal to df.sepal length centimeter, df.petal width centimeter, df.petal length centimeter, where I pass CMap is equal to my CMap, and here I pass color is equal to like this. So it give me the output like this. So as you can see, I point my all the data. I place my all the data in 3 diagram. So what is the need to use 3 diagram? Let me discuss it in one note. So basically, sometimes in a machine learning, when we have a 2-dimensional data and we want to separate all this data, right? Separate all this data by a line. So it's difficult, right? As we can see here in our previous scatter plot, it's very difficult to classify the data. Here we can classify the data by cytosa, because cytosa is far away from virginica and versicolor. So we can easily separate cytosa, but we cannot separate iris, versicolor and virginica, because there is some data points which is misclassified, right? To separate that, we transform this 2D dimension to 3D, right? So we can separate all these 3 type of classes with the help of hyperplane. So sometimes when we cannot separate a particular data in 2 dimensions, so we can increase dimension. So whatever, after the increasing dimension, whatever separate tool we have, we can separate those data with the help of this tool, right? So this is that's why we increase the dimension basically. After that we have another topic is called line plot. So when we use line plot, first of all, as a scatter plot, when we have a numerical, when we have a data like numerical continuous versus numerical continuous, at that time we plot line plot. So basically it generates all the dots, whatever dots occur in the plot, it connect all the dots and create a line. So basically it's called a line plot. To create such plot, here we are going to write some queries before plotting a line plot. So I want a list of sepal length. So basically I'm writing df.sepal length.centimeter. With the help of this code, I'm just plotting the column value. the column, and now I only want values of this column. Then here I can write like this, and I want to convert this array into the list, so that's why I'm writing like this. After that, I will store whatever value, whatever list we have. I want to store that into sepal length list variable. So after that, I am shorting this array for my simplicity, and here I'm going to print that list, right? After printing this list, I also want another list which is called a petal length, right? So I sort this. Now I also list for petal width and sepal width. So here I'm using, here I got all the 4 values of the columns. First of all, sepal length, petal width or sepal width. Now I'm trying to plot a diagram or a graph between sepal width versus sepal length versus petal length or versus petal width. Here you can see that I plot 2 diagrams in a one. So first plot is a sepal width, sepal length versus petal length, and I color them as red. So this one is a diagram which represents the sepal length list versus petal length list. As you can see here we have a line style is semicolon. In the other diagram we have a sepal width list and this is petal width list, and the color is brown and the line style is like this. Okay, so here, so as you can see here, sepal width, most of the flowers have sepal width is between 2 and 4, 2 and 4.5, whereas sepal length is between 4.5 to 8, right? So this is the date insights that we gain from this PDA, from this plot. Here I'm going to Seaborn. Seaborn is another library which is working same as like Matplotlib, but in Seaborn we can visualize the data in a better way than Matplotlib, right? So I'm plotting line plot. In x-axis I use sepal length list, and the y-axis I use petal length list, and as a hue means how many data, how many different classes we have. According to that, I divide the whole line into 3 colors. So as you can see, we have 3 classes. So blue color represents the iris setosa. This orange color represents the iris versicolor, and this green color is represent the iris virginica. With the help of this style, right? If I do not write this parameter, then I only get this. But here I want to provide a style, so here you can get this difference. Okay, so here, so after plotting this plot, you can get that iris setosa has sepal length between 4.3 to 5.5, whereas iris versicolor has a sepal length is between 5.5 to 6.7. But is it true or not? Because here we have some overlapping. How can I know that? I will walk you through this problem in up my in incoming times. So here you can see that I also plot a diagram between sepal width list and petal width list, and also do the same thing, u is equal to df the species. And here as you can see, we have a iris setosa flower which has the sepal width is between 2 to 3, and where is the iris Mossy color sepal width is equal to something like this, and iris width is equal to something like this. So here we have a better separation. After that, if we go here, so here we have sepal length is like this. Possible sepal length is varies between 4.3 to 5.5, and the it was a Setosa sepal length, where we have a sepal length of possible is 5.5 to 6.5, and sepal length of Virginica is 6.5 to 8. Okay. So now if we move forward, so why I use 4 plot, right? Because I want to establish a relationship between two variables, every two variables, and as you can see, this is a very hectic process. To avoid this process, we are going to use a pair plot, right? So here I just need to pass a data frame, and it gather all the columns, and it plot a relationship, so it the diagram between all the columns. So as you can see here, I have 4 plots. Sorry, I have 4 columns. The first one is the petal width, petal length, sepal width, and sepal length. So it plot a diagram, all the diagrams, right, with all the 4 columns, right. So I have n square. I have n square diagram to plot all the relationship. If I have n variable in pair plot, then it will generate n square diagram to represent all the relationship between all the columns. So this is the limitation, because in the machine learning we have multiple dimensions, n dimensions data. Sometimes we have n dimension data like 300 dimension, 200 dimension, 400 dimension. So it is nearly impossible to plot plot pair plot for this kind of dimensions, because as you can see that if we square this number, then it will be huge, right. So we need to avoid this stage. So here is the limitation of the pair plot. We can't plot pair plot for 300 dimensions because it's too lengthy, right. So here we go for histogram. So what is the need of histogram? So if we before we go into deep dive into histogram, let me introduce some of the topics called Gaussian distribution. So in the probability and statistic, probably you learn Gaussian distribution. Gaussian distribution, or either it's also a normal distribution, and also we can include. Also, we have another name called standard distribution, right? So if you want to check that your particular column follow this distribution or not, column follow this distribution or not, at that time you can use histogram. So that is the main use of histogram. So basically that's why we use histogram. So another topic I want to cover in this video is univariate, bivariate, and multivariate, right. So first of all, whatever univariate is, univariate means the graph that we can plot with the help of only one variable. variable. So that kind of analysis is univariate analysis, right? After that, the graph that we can plot with the help of two variables, it is called a bivariate bivariate analysis. So, and if we use multiple variables to plot a graph, then we can say that there is a multivariate analysis, right? In the univariate analysis, the example could be line plot, scatter plot, etc. Whereas, sorry, this could be the example of two bivariate analysis. In the univariate analysis, we have a histogram, bar plot, etc. Okay, and in the multivariate analysis, we have a pair plot, right? Okay, so how histogram is work? So basically, in numpy library, we have a function called histogram. Basically, in numpy dot histogram, in which we need to pass a variable or a column that contain all the values, and second thing is density. If density is true, that means whatever value it returns, that value would be the affect by the probability density function, by the calculated by probability density function. Now the question is, what is the probability density function here? So probability density function gives you an idea that what is the frequency of each data point at a particular range, right? So basically, here is a x and y. Yeah, I know my drawing is not good enough, and the range is like 10, 20, 30, 40, 50, or 60, right? And here I'm going to write 1, 2, 3, 4. Okay, so first of all, the number of data points occur between 10 to 20 is 2. So this 20 to 30, so it's 3. The number of data points occur, the value is between 20 to 30 is 3. 30 to 40 is 4, right? After that 53, and here is 2. So numpy.histogram provide return two values. First of all, the values is the number of bits. It return this continuous value, and also the returns that how many, if we do not write density is equal to 2, and if we write density is equal to none, then it will return the number of frequencies. It will return the frequency of a particular beam, right? So like this. So in the first we have 2, second we have 3, 4, and here 40 to 50 we have 3, 50 to 60 we have 2. So this is the first array, and in the second array we have values like this: 30, 40, 50, and 60. So this function does this value, and if we write density is equal to true, and this function returns the probability of this occur, right? Probability for this occur. So now what is the probability density function, right? So probability density function means if we, so there is another two concept. First of all PDF and second one is the CDF, right? So probability density function means density, right? A density of particular element, a probability of particular element. At that time, whatever value we get, it is called as a probability. It is called that this function is calculated by the density function. So suppose here we have a function and I want a value between 10 and 20. That particular data point, how many times a particular data point occur between 10 and 20. So two times. So it provides me, this function provides me exact value. So this is called as a probability density function. Whereas what is CDF? So basically, so if I write that how many data points occur before 60, sorry, before 40, how many data points before 40? So I can write like this. So there is some data points that occur before 14 and it is 2 plus 3 plus 4. So here we got multiple values, not an exact value, right? So this is called as a cumulative density function. We can calculate cumulative density function with the help of PDF. We need to add previous probability density, whatever value we get from probability density function, we need to calculate to each other and we come up with a particular value. It is called as a cumulative density function. Let me implement this for you. So here, going to first plot a histogram, we have a function in matplotlib called hist, in which we need to pass the particular column. So here I am providing sample length list and it gives me two values. First one is 9, 23, 14, 27, 16, 26, 18, 6, 5 and 6. So this is basically the, here I told you that this is basically number of frequency, right? So here you can see that between 4.3 to 4.66 we have 9 data points. 4.6 to 5.02 we have 23 data points, as you can see here. To more specific, we can plot this diagram in a Histplot. Sorry, in the Seaborn library. Seaborn library we have a function called Histplot, right? So here we can see the lines between one bar, between two bars. So here, so basically it doesn't return this kind of arrays. To get this kind of array, to be more specific with numbers, we have a function in numpy called histogram, right? So here I want a sample length for setosa flowers. So I write this query. So whatever I got from this query, I try to be more specific and get a sample in centimeter column, and after that fetching the whole thing, I only need a values from that, and whatever values I need, that will be in the array, and so I need to convert that into list and store that list into sepal and cytosa, right? So now I try to print that sepal and cytosa, whatever value considered in sepal and cytosa, that would be plot it would be follow Gaussian distribution or not. So that's why I print here. So this the particular list is follow Gaussian distribution. What is a Gaussian distribution? I will describe in my probability and statistics videos. But let me give you some introduction about it. So whenever a particular column, right, particular column that follow a Gaussian distribution, at that time you can say that your all the data points is covered by the Gaussian distribution, and whatever data point is not covered in the Gaussian distribution, you can consider them as an outlier. So you need to remove them, right? Okay. So here I'm going to import numpy as np, and here I'm writing np.store, in which I need to pass sample length setosa and number of bins, and density is equal to 2. Number of bins is not mandatory, right? So here I give here it throw two values. First one is a hist, and second is a beans. Hist means it throw a value which consider a probability density, which considers some value. It is the frequency of a particular data point that occur between two values. Like here you can see that here we have a bins. Just okay, hold on for a second. Here, so between 4.3 and 4.5 we have a probability of data point is 0.4. 4.5 and 4.8, the probability of particular data point occur is 0.48, right, and so on. So after this I need to convert this whole into a PDF probability density function. So I need to pass this hist function divided by sum of hist. So I need to, okay, so that's why this is normalized, right, and the value of PDF is varies between 0 to 1. So here, as you can see, now this PDF is normalized, and if I want to sum of this, then I get 1. Okay, yeah, so this how this works. And after that, here I'm again print names, and now it's time to calculate the CDF. As I told you before, we need to calculate PDF, right? We can get CDF by using PDF. We need to how can we calculate CDF by merging, by adding two parts like 0.1 plus 0.12, right? And this how we can get CDF, right? Okay. So now here we're going to print a line plot. So in the line plot we can get values. We can show a line, right? So what is the insight that we gain from this? So here we can say that there are 500% chances the values of Setosa flower is less than 5.8, and here you can plot 0.2 means 20% chances the value of Setosa flower is 4.8 plus 4.8, right? So what does that mean? Suppose we have a graph like this. Just a second. Okay, so suppose we have a graph like this. This is the x-axis, and here it is 1, 0.8, 0.6. So as an example, we have like this height. So I want to know that what is this? What are the portion of flowers have size less than 50.2. So I point 50.2 and check the portion of the size. So here I get that 60% portion of the flowers have 60% portion of the flowers have size less than 5.2. So in this way we can calculate, we can use PDF and CDF. I give you another example. Suppose you are working in XYZ company, and as a data scientist in this company, right? You are a data scientist, and this company wants to give its all employee a t-shirt. So your task is to identify that how many t-shirt we should order each of each size. So because in the t-shirt we have M size, L size, XL size. So you have a task on the basis of the height. You have to calculate that how many portion of t-shirt we should add, like how many percentage of t-shirt we should add. Okay, so you will plot the CDF same graph, and here we use the height 180, 160, or something like 160, 170, 175, 180, like this. And on the basis of that, if the person height is less than 160, right? So you can see that there is a 20% employees which has height below 60. So for those we can buy L size of t-shirt. For those who has a height is below 160 and below 170 and 160. 160 sizes below 170 and greater than 160. So for those who can, we can buy 40%. We 20% of for those, and for those who have a size is 180, we have okay, so 90% of this employee who has a size is below 180. So this is the thing that you can gain from the CDF and PDF. So that's all for now. Thank you for watching, and